My name is Tim Schoenrock, a graduate student with the UF Edge program, and this is my presentation of the project I did for EEE 6512 Image Processing and Computer Vision. I did my project on a face detection and image swap. I basically wanted to take a video source, run a face detection algorithm on it, and then replace the face with a known image, sort of like a Snapchat filter does. So, looking at the code, I first import all of the necessary libraries, and then I define the cascade classifier as the hard cascade frontal default or face default XML. In an image, you can have hundreds or thousands of different mathematical features that define something. And so in this cascade classifier, it splits up the image into multiple regions, and one by one, they're searched for a small selection of highly probable features that, say, would exist on a face. And if there's not enough of these features in the region, then the region is just automatically discarded and it's not searched again. But if there are enough of these features, then it goes on to a second iteration where it searches for more features, and they're a little more obscure too. So this cycle continues iteration after iteration until the classifier cascade eventually decides that, hey, there's probably a face here. So obviously we're looking for faces. We're using the frontal face classifier. And then I get into my argument parser, which is pretty much the input arguments I put in when I'm starting my program. The first one is required because it's the output file. The next two are going to be ones that I haven't quite implemented yet, but they're going to be what input video and input image you want so that you don't have to manually code it, as you'll see later. The next one is frames per second, which is pretty self-explanatory. And then the last one is the compression algorithm. So then we're getting into the actual code. So I'm defining VS as my video capture. So you can either use like a preloaded MP4 file, or you can even use the video stream from the webcam if you just put a 0 in the argument. Right now we're using an MP4 file, and then a little more compression algorithm setup. We're going to be using the MJPEG, and then I go into loading my image. This one is a puppy image. It's very important to define the second argument of this image read as -1 so that you can import all 4 of the layers as opposed to just one. I was originally having trouble making a mask that would work with my video filters because they only had 1 layer as opposed to the 4 that the video has. Then I go into making the masks. This is defining it as 4 layers, and then this is running a bitwise operation to invert the mask. So you have one mask, you flip it inside out, you have the other one. And then you take the shape of the mask and the image. It's not too hard. And then we get into reading the actual frames. So we'll just call this frame 1. We're going to resize it to a width of 720 so that it's not too big, not too small. It's kind of consistent. Then we're going to turn it into a grayscale, and then we run our face detection algorithm. So I have 3 parameters that I've set in this. The first one being the image, called gray. The second one being the nearest neighbors parameter, and that's the third one. The second one being the detection speed ratio, and then the third one being the nearest neighbors parameter. The 1.1 is the slowest possible detection speed ratio, and it gives the highest percentage of correct detections because the algorithm is essentially able to run more passes through it. Excuse me. The nearest neighbors parameter is set at a maximum of 4, and it, from what I understand, looks for a face to be detected 4 times previously before it will be sure that, hey, that's a face. So ideally, this is set at highest percentage of correct hits. Sometimes it works, sometimes it doesn't, but you know. And then we get into each face. When I was debugging this, I had the rectangle drawn around each face. That was pretty helpful, but we don't need it here. Originally, I had the face and the image that I was putting over the face at a 1-to-1 ratio, but I realized that the image wasn't covering the face completely, so I pretty much just made it 2 times as big. And I had to do some funky math because images only take integers, and sometimes these numbers were odd and they wouldn't divide evenly, and I get errors. So I pretty much recalculated the width and the height of what my face would be when it's 2 times the size. And then, let's see, we're resizing the color image to, which is where I get my masks from. And so here we make a mask from the colored image. Oh, kind of. We make it from the original mask, but pretty much just resizing the masks and then defining regions of interest. We define this in the color and the grayscale because we're going to apply the masks in the grayscale, and we're going to put the final images into the color. And then this is applying the mask. And then this is just adding the masked image to the final colored image. So the reason we use masks in this is because not everything is going to be a rectangular image that we want to implant. So if you want to put, say, a circle, you can't just say from X to Y to X to Y. You need to define a bitwise pixel dependent image or object. It's a terrible description. And then pretty much after that we just write this new frame to a new video file. This is taking the shape of the frame, writing it in our original arguments that we put in the beginning, and then using a unsigned integer, 8-bit integer. And then you can hit Q and 1 at the same time and it'll break the loop, or if you're using a preloaded video file like me, then it just breaks after it's finished running. So we'll try a little test run of this code. I just have to get to the right directory real quick. Okay, so we're going to be using proj.python, And then here's where I put my output argument. We'll call it Bruce Lee 1. And we'll use an AVI extension. And as you can see, there's a puppy on the face. Oh, went a little crazy there. It went really crazy, actually. So that's what it looks like. I clearly have a little more debugging to do, but as a proof of concept, it works pretty well.